Hello students, welcome back. The second method for systems of linear equations is elimination method. Let's go back to the very same example problem that we studied before. 2x plus 3y equals to 6, the first equation, which I'm highlighting in blue. And x plus 4y equals to negative 1, the second equation, and let me highlight it in red. Okay, here the key is to subtract one equation from the other to eliminate some character. I can't do it right away because 2x minus x is x, 3y minus 4y is negative y. Neither disappear. But it is possible to multiply something to the second equation and then set up the elimination like this. Multiply by negative 2. Well, same as multiplying by 2 and subtracting. So multiply by 2. Oops. And then you can subtract one from the other. But then again, usually students find it easier to do addition than subtraction. So our textbook author suggested instead of just multiply accordingly and subtract, multiply negative so that we get 2x and negative 2x, and then negative 8y and positive 2. And then add them together. That's the same. Multiply negative 2, distribute it around everything in second equation. We get this equation down here. And the previous second equation and the new second equation are the same. Just multiply by negative 2. That's why they have the same color. Now adding, we get 2x minus 2x, oh, that's gone. 3y minus 8y, so negative 5y. 6 plus 2, that's 8. Therefore, we get y equals to 8 over negative 5, or equivalently speaking, negative 8 over 5. There goes my solution. Now that I have y value, I can find out the x value. How do I do that? One way is to substitute this y value back into the original equation, either first or second, or maybe third, and then do your simplification and then find out x value. It works, but in many cases, people repeat the same process and this time eliminate y to find out x value. How do you do that? 3 times something, 4 times something, excuse me. So 3 times something, multiply by 4, multiply by 4, and multiply by 4. And then down here, multiply by 3, multiply by 3, multiply by 3. And then we can subtract, then 12y will be gone. But then again, a lot of students find it easier to do addition instead of subtraction. So let's do it this way. Multiply the second equation by negative 3. So you get negative, negative, and then this will now become positive. And then if I add them up, what do you get? 8x minus 3x is 5x. And 12y minus 12y, that's gone. And 24 plus 3, that's 27. Therefore, x is 27 over 5. This method is called the solution by elimination. So multiply appropriate coefficients and then either do subtraction or addition. After the elimination, you're going to get one value. And then do the same. Eliminate the other variable and you get the other value. Or after getting one, you could have simply substituted all these back and then get the second value. Either way, it works out. This kind of method is called the solution by elimination method. Let's see, what did I do here? Multiply by -2. So the first equation stays the same. Blue stays blue. And then the second equation, which used to be red, let's keep to something close to red. Let's see, orange? Okay, orange. Orange is not strong enough. Magenta. Okay, red equation became magenta equation here. Close pink. So multiplying by -2, we get this. So it's the same as red equation actually, expressed a little bit differently. But now I can add them up to remove this x altogether. So this kind of method is called the elimination method. And it works for the other variables too. The other variable, what am I talking about? Let's see. Yeah. And then here, cross multiply. Multiply by 4. Then that's become 12. So multiplying by 4, 8, 12, 24. And then here, multiply by 3. Cross multiplying basically. So that'll become 12. And multiplying by 3, 12y, 12y, so I can simply subtract. But of course, when you subtract, it's the same as adding negative of these. So we can do the sign change. And then adding. That's how you get 5x equals to 27. Yeah, 12y, that's going to be gone. We can do it like this. In this notebook, as a matter of fact, I mixed up, get one value and plug it back in, get the substitution, and then getting this answer like this. So I'm kind of mixing up substitution and elimination. And there is an advantage to this method too, to tell the truth. But the full-blown elimination method is something I just showed you. In any case, if you prefer this elimination method, go ahead and use it. The majority of the students, majority I mean by overwhelming majority of students, go with substitution. Only a small number of students find it easier to go with the elimination method. That was my experience, to tell the truth. When I was a student, as a matter of fact, I was one of those minorities, so I used to prefer elimination method. Let's see, do we have enough time for elimination? Well, let's see. Let's go with the first problem. Multiply something to the first equation. So that I can set up appropriate addition or subtraction. So what would you do? First, I'll multiply 2 to the second equation. And the first equation, I didn't do anything. I'll just multiply by 1. So no change. In other words, I'll do this. No change to the first equation. Multiply by 2 to the second equation. And then, of course, the reason must be obvious by now. We have minus 2y plus 2y. Adding up, they'll kill each other out. 7 plus 8, we have 15x equals to, let's see, 1 minus 4, that's -3. X is therefore 3/15, but that is 1/5, -1/5. Okay, I got 1. And then plug in this x equals -1 to each of these, either first or second, either one, and then you can solve for y. That's one way to handle it. Another way to handle it is to do something like this. Multiply something to the first equation, multiply something to the second equation, so that this time I can eliminate x. What should I select? That's the original. Copy the original once more. 7, 4. So they're relative primes, so I'll just cross multiply. Multiply by 4 to the first equation and multiply 7 to the second equation. So multiply by 4, 28, multiply by 4, multiply by 4, and then about the second equation, multiply by 7. Multiply by 7, and then multiply by 7. Okay, if I subtract one from the other, then that way I'll be able to eliminate this 28x. But subtraction, often a lot of students find it harder to do the find it harder to do the subtraction, excuse me, not substitution, subtraction. So instead, multiply by -7, then we get -28, and that's -7, and that's +14. So that I can add them up. So 28, 28, they go out, and then we get -15y equals to 4 plus 14, that's 28, right? So y is therefore 28 over 15, negative of that. All right, did I do this right? Is the answer supposed to be this complicated? Oh, x value is right, y value is not right, so I may have made a mistake here. Please stop the playback and find out. What did I do wrong? Sorry, it was a trivial mistake. 4 plus 14 is 18, not 28. So 18 over 15, yes, it simplifies okay. So yes, the answer I have over there is correct. Okay, so much for elimination method.